Hello, welcome to chapter 11. Today we're talking about significance tests. And significance tests are what we're doing the entire rest of the year. Uh, Now they are used everywhere from medical field to psychology. Anytime anybody does an experiment, generally a significance test is performed. And a significance test is just a formal procedure for comparing observed data with a hypothesis whose truth we want to assess. So if somebody has a claim, uh, say I make the claim that I can shoot um, a 10 out of 20 basketballs and make a basket. Um, then I make that claim, and then we go out and test it to see if that's actually true. And a significance test is what helps us tell us whether or not we think the person is telling the truth or not. We're going to use this example for a couple different things, but this one is called Call of the Paramedic. Several cities have begun monitoring their paramedic response times. In one city, the mean response time to all accidents involving life-threatening injuries last year had a mu of 6.7 with a standard deviation of 2 minutes. The city manager shares this information with the emergency response personnel and encourages them to do better for next year. At the end of the following year, the city manager selects a simple random sample of 400 calls involving life-threatening injuries and examines the response time, and he found it to be 6.48. Our question is this good enough evidence to show that times have improved? This is what significance tests do. They let us know whether or not we're making improvements or if the variation is due by just chance alone. Now in this case, we can find the mean and standard deviation of the sampling distribution expected for 400 samples. The mean is going to, the mean of our situation, which is x bar, is going to be our previous mean, which is 6.7. Now our standard deviation of x bar is going to be our former standard deviation, which is 2, but now we're going to divide by the square root of 400 because it's a mean of 400. So now we take out our trusty calculators, and 2 divided by the square root of 400, I come up with 0.1. So without doing any calculations, how is it likely that we get below time of 6.48? Well, it's a few standard deviations, more than 2 standard deviations below the mean. So that's probably going to be something that happens pretty rarely. So if we graphed out the normal distribution, where we have our standard deviation and our mean, having something like 6.48 is so far away from this mean that we would say that this is enough evidence to say that that mean isn't truly the mean. If it was something like 6.61, well, that can happen just due to variation from sample to sample, but not something as far as 6.48. And we'll explain more about how to do the math of that in our next videos.